So now we are going to see the introduction of CW radar. Historically, it is the first radar developed and used for the short range detection of the target. Started detection of target. The targets operate with continuously high frequency carrier sinusoid. So we can find rate of velocity our target is approaching, that is closely or receding. Requires separate antennas for transmitting and receiving signal. Minimum isolation is required. Because why minimum isolation is required is here we are using the separate antennas for the transmitting and the receiving to avoid the leakage power, and the antenna is affected by the transmitting power. So what is the disadvantage is, so a main disadvantage of CW radar is no time marking. So what do you mean by the time marking is, that is no starting and ending position of the pulse, no possibility of range measurement. So is we cannot calculate the distance between the transmitted and the received signal. So application main use in surveillance radar, mainly used in the surveillance radar. So what is the main drawback of the basic radar is, basic radar is used the same antenna for the transmission and reception of the signal. We can use this type of radars when the target is stationary, that is not moving, and or when that radar can operate with pulse signal. So we are going to the CW radar. The radar which operates with continuous signal for detecting non-stationary targets is called continuous wave of simple CW radar. The radar requires two antennas, among which one antenna is used for transmitting the signal and other antenna used for the receiving the signal. So this is the basic block diagram of simple CW radar. This is a modification of basic radars. Basic radar diagram lo basic diagram ne use chesi, basic block diagram of radar ni use cheskoni CW radar ni use chestam. Here the CW transmitter, there are three blocks: CW transmitter, detector and Doppler. So that is CW transmitter, and another block diagram is there: CW transmitter, detector, beat frequency amplifier and indicator. So here in CW radar transmitter radiates the continuous energy in the form of unmodulated sinusoid at F0. A common antenna is used here which will transmit the energy and as well as receive the reflected energy. According to the moment of the target, the reflected energy frequency will varies. So here when F0 plus FD increases, F0 and FD sums and get the increased frequency, then we can say the target is closing to the radar. So when it appears, when it is going to be done, when the received signal frequency is greater than the transmitting signal frequency. If the target is moving away at the received energy, will have frequency, that is when the received signal is less than the transmitting signal. So the received echo signal at frequency F0 plus or minus FD enters the radar via the antenna and is heterodyne in the mixer. So detector with the portion of the transmitting signal abnormal to produce the Doppler beat frequency FD. We are taking some reference signal for generating the beat frequency. So if after the in the input of the detector we are giving is F0 comma F0 plus FD or F0 comma F0 minus FD. So we are appearing the FD. Beat frequency amplifier or Doppler filter is eliminate the echoes from the stationary target and amplifies the Doppler echo signal to the level where it can operate. So here indicator, earphones, frequency generator, frequency meter and audio phone. So what is the use of Doppler filter? So Doppler filter, so the detector what produce the output frequency that then further passes it on to the Doppler filter. So the Doppler filter is nothing but a low pass filter. It allows the low frequencies and rejects the high frequencies. The low frequency cutoff must be high enough to reject the echoes caused by the stationary target. The upper frequency cutoff level is decided by the maximum expected radial velocity of the target. If the filter passes different frequencies, so we cannot identify the direction of the target moment. So if the filter passes different frequencies, so here the Doppler filter is nothing but the filter bank. Doppler filter is nothing but the filter bank. So here below figure we can see the response of beat frequency amplifier or Doppler filter. So to find the radial velocities, so we are modifying the diagram of CW radar, sign of radial velocity, and which is in which direction it is moving. The positive radial velocity indicates the distance between the object is or was increasing. A negative radial velocity indicates the distance between the source and observer is or was decreasing. So a plane flying past a radar station, the plane velocity vector is the sum of the radial velocity and the tangential velocity. So here we can see the three colors of lines. One is green color, one is red color, and one is blue color, where the red indicates the plane's velocity vector, and where green indicates the sum of the radial vector, and blue color indicates the tangential velocity. Blue color indicates the tangential velocity. So this is the modification CW radar. Here what we are going to do, we are using the separate antennas. So next after that we are using the CW transmitters. So CW transmitter and synchronous motor indicator. So here we are using the two mixers, mixer A and mixer B. So first mixer key we are giving the CW transmitter as a reference signal, and we are taking the receive signal. For the second mixture we are giving the transmitting signal with the phase shift of 90 degrees and the receiver signal directly. So we are forming a two channels, channel A and channel B. So that was given to the synchronous motor. So here we are estimating that transmitting signal ET is equals to E naught cos omega naught t. Received or echo signal is ER is equals to K1 E naught cos phi. Mixed output signal is gives EA. Mixed output signal is EB. If the closed target, we are going to get EB will be lags with the EA by lambda by 2. If EA is leads by EA by lambda by 2, so the motor runs in one direction. Here what we are going to do, we are going to find the direction of the target. What you are going to do, here we are going to find the motion of the target.